Okay, so we're recording. Okay, so hello, I'm Alex. I will be your host today in today's Konveyor's community meeting. I don't see any new people here in the meeting today. Let me check again. No, so then we can move right away to the demos. I see that there is a demo from Ideswari, Savitha, and David. So if you want to go ahead.
You want to see the screen?
Yeah.
Percent noise. Right. Everything looks okay so far? It does, yes. All right. So I want to give a few weeks ago, we talked about the enhancement to introduce this agentic controller. And the idea was to do AI powered migrations using agents and run these on Kubernetes OpenShift. So this is meant to kind of give us an update on where we are. So just for background, since we're recording, we're going to start with like what the agentic controller is, talk about that CRD architecture, just so that we stay consistent with what's, as we transition from the enhancement to actually implementing things, so we can just keep up to date. How this fits into the overall Konveyor ecosystem with the hub and the UI, talk about the end-to-end flow, the harness, and then the demo. It's nice. That's the part Hiteshwari and Savitha are going to show you. The agentic controller is a Kubernetes controller for managing AI agent workloads in Konveyor. So what it defines is some domain agnostic CRDs for composing, executing agent tasks. It leverages the agent sandbox. We'll talk more about the agent sandbox and some of the other projects later for the isolated execution environment. Decoupled from Hub, the main reason for pointing this out is really just to say that it doesn't, what you see at the bottom, right? It doesn't have domain specific knowledge about Konveyor specifically. It doesn't know directly about applications. It sees desired state and it makes it happen. So these controllers are pretty dumb. And it's just the main thing. The intelligence comes from the hub and the UI. So just a little bit on the CRD architecture. We have skill cards and skill collections, so we can define skills. Right now in code, what you'll see is just we reference container images. Those are OCI artifacts, and skill collections can point to a group or a collection of skill cards, and we mount those in as volumes, read-only volumes into the pod that eventually starts. LLM provider, so there's the LLM endpoint credentials, model catalog, and then we have the agent and agent playbook. So an agent playbook is an ordered sequence of stages referencing agents per stage. The execution resources that we have, there's an analog here to what's happening with Tecton, the task run, and Tecton pipeline runs. The agent runs a concrete invocation of an agent with specific values. And a playbook run is a very similar concept, but just a sequential set of agent runs. Design principles for what we're going after, domain agnostic. So it validates, it creates sandboxes, tracks lifecycle. It doesn't specifically call out to the hub or backstage or any other interpreter of parameter values. It's pretty simple by design. Agent sandbox is a hard dependency. Get credentials, stay in the harness. So what we're trying to do with some of these things is prevent the agent from having direct access to credentials. The UI connects to agent pods directly for ACP streaming. So this is, you won't see it in the demo today, but there are So Goose is right now the only agent orchestrator that has this ACP streaming support. But the idea is we could support things like human in the loop in the future, and the UI could show what's actually happening inside the agent as it executes. And the design principle, like what the goal is for the hub to provide curated best endpoints as the API surface for the UI. So just quickly talking about what we're going after is for the hub to expose these purpose-built endpoints for these agent resources that we have, and the words that are kind of flowing off the screen. The agent run creation is a smart endpoint. The idea here is that the UI doesn't need to know the specific shape of agent runs and agent playbook runs in order to fill in things like the source URL for the application and its credentials. The UI can just say, hey, run this agent against this application with these specific instructions, and the hub can translate that into a correct agent run or agent playbook run. The hub would also be the one that would be like sort of the proxy for that ACP WebSocket to agent pods for that stream. The UI talks directly to the hub. There's no Kubernetes API, no raw CR work. The agent streaming, but this is still proof of concept and syncing phase. The ACP WebSocket is proxy through the hub. There's the idea of the human in the loop and the idea that multiple clients could connect and replay the history on join so it could see all the things that have happened. So the UI hub run agent X on application Y. The hub resolves the get URL credentials branch, and it creates the agent run CR. Our controller, the agentic controller, reconciles those into an agent run. It creates a sandbox CR, and it starts to pod with the harness. And then the harness is the thing that makes all these things come to fruition. So just a little bit on the harness. So the idea is that we have this Go binary entry point that is in the base images that we use for this work. It handles the Git lifecycle, the clone, configuring remotes, the commits, and the push on exit. It's the thing that starts the agent runtime and gives it the initial prompt and is making the credential isolation part possible, like preventing the agent from having push access to these repositories. There's the idea of these handoff files for continuity. We talked about it in the enhancement, and I may have glossed over it on this one, but the idea is when we commit to the repo, we include everything, all the decisions that were made by the agent for sort of transparency and for handoff, so that we would have, find it really quick. So we have this like .konveyor directory, and that's where all of those types of decisions that have been made and what we've come across so far would be stored. So subsequent stages of an agent playbook would be able to reference those decisions that have been made as it progresses. So multi-stage playbooks. And the idea here is that we could have something like an analyze, the code analyzer, detect migration targets, produce a plan, migrate, verify. Each stage runs in a fresh sandbox with fresh context window, all that cool stuff. And for the demo right now, what we have is this PR number 33 on the agentic controller repo. At the end of I'm going to link to the slides, which will also be a link to the repo for you to see. Like if you want to catch up on what we're doing, that's where it all is. Right now, the idea is for it to serve as sort of a mono repo for all the work that we're doing, and then we can split it out into some other repos if we need. But the migration harness includes the CLI, the init, run, and status, and it runs the full workflow, detect, plan, execute, verify, and fix. Sorry, I scrolled my mouse. There we go. The Git credential handling, recipes, skill bundles, and this is where Hitesh and Savita will walk through the actual implementation. So I'm going to save the demo for last. Where we're headed to next is, and very soon we're going to be accepting the PRs for 33, which is the harness and the client stack. This is the work that Ian has been doing. And PR 36 is the playbook controller, so playbook and playbook run. Areas in the roadmap in the short term are the OpenShell, moving to OpenShell so we can pursue those integrations. Tecton custom tasks, this is kind of idealistic, making it so you could run in say a Tecton pipeline, a CI pipeline, you could actually execute an agent to do sort of a code rabbit type review. Expanding on the scorecard resolution to do Git repos and inline markdown and convert them into an OCI artifact that could be used in the skill. That's more of like UX polish so that Konveyor users would be able to define skills in line and manage them in the UI. There's work around the memory service so we can have persistent knowledge that's across runs. We can accumulate knowledge in these agents. And production images really just continuing to polish the idea as we move forward. And the next thing up is the demo.
I can take over the screen. Thank you, David. 1 second. Let me know when folks can see. I am, can folks see, do you all need the font size to be a little bit more?
Yes, that will be good.
Okay. How about now?
Better, yeah.
Okay. All right. So let me just go back to this resources that I'm going to deploy. So I'm going to take a step back and I'm going to say, like, first, I'm going to show off this harness that runs through the agent run itself. So it's like one big thing that's all bundled, all the base image for the Goose agent runtime, Goose, and then like the migration harness, everything is bundled into one image and it's built and it's available right here. And then this is the agent run that we create, like from the UI, it's going to be coming and then the controller created for the sake of the demo. I'm just like creating it here and I'm providing the Git URL tokens and stuff like that. All the things comes from the environment. I am going to go ahead and apply this thing. And let's see, the logs are clear. Sorry about the things. All right, so it has multiple steps like as, oh, that failed terribly. Sorry, that is the beauty of the live demo, but I'm just gonna show something that I just ran 2 minutes ago. So what happens is that it, when we create the run, it first runs a plan step where it's going to use Graphify to find the dependencies and whatnot. Once it finds the dependencies, it passes to the planning stage. And when it passes to the planning stage, the planner skill takes those information in, and then it has a migration skill saying that, okay, I want to migrate from Quarkus, Java EE to Quarkus. It's going to take the skill, and it passes that to, like, takes a reference, passes the skill, and then it works as an agent, and it creates plan.md. And when it creates plan.md file, I can just show it to you. I have a run. Luckily, I have a run that was done 5 minutes ago. So let me just show the plan.md. So what happens is that it creates this whole plan.md file. I'm sorry, I'm just scrolling too fast. So if you can see, like it says, like it was, it takes in all the things, and then it also creates this order of migration, what files to migrate first, and then it will also have an information on like steps that gets passed to the execution step. Once that is done, the planning gets auto-approved. For the sake of this demo, we are just auto-approving stuff. So these are all the planning MD file that gets written into the Sorry about that. I'm so frazzled because my live demo didn't work. But anyway, so the planning gets done, and once the planning gets done, it's gonna send to the execute step. And what happens? The execute step is that it takes one after one what was done in the planning step, and then it starts executing those little things in the it creates a new use server session, and then it executes that little bit, and then it commits it back. And that is one of the things that we have been focusing on, to do incremental commits as we are working through these migration. The container is, the pods are ephemeral, the containers are ephemeral. We don't have any volumes attached. So one thing that we want to focus is that everything that gets migrated gets pushed. So all the things that that gets executed in the plan step by step, it gets pushed to Git. And then there is this last step that does this verify, and it will run the code, and it sees that if it compiles cleanly. If it doesn't compile, there is this loop. It goes back with that information, what's failing, to the agent, and then the agent will take that information with the context of, okay, this file's failing, this is the error, and then it'll go back and it will fix the code, and then it'll run for, like, I have put 3 iterations for fix loop, so it'll run 3 times trying and fixing it. Once it's like done, it'll say like, okay, Maven compiles clean. In this project, it does, because this has been the one that's been testing. We have been testing a lot, and it pushes everything to the Git repo, and we can go and see the Git repo. It also has this nice summary that you can see here, and this is the execute step that you can see, like every one. It starts execute step here, and then like it's step 1. I'm going to migrate this file because this is the high priority important file. I'm migrating this file, and then once it's completed, it gets pushed to Git, and there is a checklist that it goes through. And let me just go up and show the commits that it has made. So we can see, like, first steps detects complete, plans complete, and then its first step, it just migrate the POM file, and then it keeps on migrating every file which is in the order of priority that it identified, and that was done using Grafify. Grafify finds these dependencies and high priority nodes where it says that what needs to be migrated, or what is the priority file that we need to migrate first in order for easy migration. So all these things are experimental, and they're gonna they might change eventually, but this is the current state, and I'm showing the current state. So it migrates all the files, and then once it's done, it does create a handoff. Handoff is created every stage, and then it'll also update the handoff file right here. So we can see, like, it has a nice summary that this gets passed to user whenever we are streaming. So it says, this is a request, this is summary, what was migrated, and then it says like what needs attention. These 2 files need manual attention, and then this is the verification. Whatever that we have, the build is passing, and we don't have any tests for the repo, the app, so we are not running any tests. So it says like 0 pass, 0 failed. And this is what this is running using the agent run. This is all like one big giant thing composed and put in one single image, and that's running through end to end. I did work yesterday through what David had for agent playbook run, and luckily I created a video for that. So I'm gonna probably jump onto that to show a little bit on that, the work that is getting done. And let me just, oh, sorry about that. I was trying to increase the, okay, the font size is good. So this is like the playbook that David described, where we are gonna go stage by stage. It's gonna be it's think of it like a composable images, things like that, composable stages. So we'll have a plan stage, and then we will have execute stage, and we will have verify stage. So here we are having like 3 agents, one's for like migration planning, migration execution, migration verification. All these images are built with some references and whatnot, and some extra parameters there. And then in the agent playbook, we are saying like, okay, this is what we want to do, migrate Java E application to Quarkus, and then these are the stages: plan stage, execute stage, verify stage. And then we create this agent playbook run, and then the agent playbook run says like, use that playbook reference we just created, and these are the environmental variables that we are passing. And let me see, where is the demo? Okay, yeah. All right, so this is very raw. I did yesterday at like 8-ish, so it's not super complete, but I'm very excited to show all the work that we have done. It's the work that David Iteshwari I have done, and Ian's EY is going to come. I just get to be the pretty face showing today with Trail live demo. So what it does is that we are creating the run book, and then it's going to take some time to do the planning. I'm just going to fast forward to the planning. So once it's done planning, it's going to commit everything. It pushes to the Git, and then it closes the server and everything, and then it moves on to the next stage, which is execute. It's going to take the Git push where we made with the plan and stuff. It takes it from the Git, and then it starts executing in this execute agent work. Once that's done, sorry, it takes about like 12 minutes. So I'm fast forwarding to the stage where I can just quickly show. So once it does complete execution, in this execute stage, what's doing is migrating all the files it identified in the plan step. It has migrated everything. It has pushed everything to Git. And the verify step is where we are going to take whatever is pushed, and along with the planning file and whatnot, all the extra files that we have committed, and the agent will pull it down, and then it's going to do Maven compile, because it's a Java application in this case. And we are saying like, oh, Maven compile, find the issues. If you find any issues, fix the issues. So that's what's doing right here. It's trying to find something file. I think in this case, it did find some issues in the form.xml and stuff like that. Then it will run to completion. And here also I have specified like 3 turns. It runs to completion, it pushes it, and once it's done, it says like it's clean. And I think I might have some, okay, I have a very Git push thing that I did yesterday. Yeah, and that's it. I have this whole thing, and my live demo failed. And I'm sorry if you all had a very bad experience, but this is the work that we have done so far, and it's very exciting. Any questions? Oh, I'm getting a lot of support. Thank you all.
Yeah, Sarita, thank you. Super cool. Okay, so thanks again, Sarita. I don't see anything else in the agenda, but I see that one person has the cursor in the demos. So I don't know if that means that he wants to have something or not.
Well, sorry,
Yeah.
I just wanted to mention that I cut a beta release like 10 minutes ago. So that would be 0.10 beta 1. If that all passes the CI check, which I know we're working to fix CI right now, if that does pass, then I will just cut the GA, because we cut the release branches yesterday. So I scheduled it for the 21st, but assuming I get a beta that actually passes the CI runs, I'll probably just GA it if everyone's cool with that. So
well, I think, don't we have I think the issue that Sveta raised. Oh, sorry, which release are we talking about?
0.10.0. which we've already tested upgrade from 0.9.
Okay, never mind.
Dude.
You're talking about upstream. We're good. Yep. I was thinking about the downstream bug that Sveta reported. Never mind.
Yeah. That's it. Thanks, Alex. I just want to call it up.
All right, thank you. Yeah, I don't see anything else. So now we have two super exciting moments. First one is when I shut up for 30 seconds to see if someone wants to say anything else. And the other one is choosing a new host for the next community meeting. So here I go.
Yeah. Now you mute your microphone, Alex, and you wait.
Sorry, again?
Now you mute your microphone and wait
Ah,
for
yeah.
someone to volunteer. Yeah.
Yeah.
I'll pick someone because I'm not doing it. So do I need to pick someone or anyone going to volunteer?
I don't mind doing
Yeah.
it. I've never done it.
One more. Good job. Thanks, buddy.
Okay, nice. Then I think that's been everything for this meeting. So I'm gonna stop the recording and then you are off.